Let's look at the definition of the derivative and walk through some example problems. The derivative of a function f of x is notated by f prime of x, and it's the limit of f of x plus h minus f of x, all divided by h, as h approaches 0. Let's now walk through some examples where we're going to find the derivative of the given function using the definition of the derivative. We're also going to state the domain of the function and then the domain of its derivative. I'm going to begin by writing down the formula for the derivative. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. Now we're going to substitute in what f of x plus h is and what f of x is. Wherever we see an x, we're going to substitute in x plus h. So this is 5 times x plus h minus 4. And now we're going to subtract off f of x, which is 5x minus 4. And all of this is divided by h. Now all we have to do is just do a little bit of algebra. This is 5x plus 5h minus 4 minus 5x plus 4. Make sure that you carry this negative through to both this term and this term. And then all of this gets divided by h. Now let's see if we have anything that cancels. Our 5x cancels, and then our minus 4 cancels with 4. So this gives us the limit as h goes to 0 of 5h divided by h. And now you can see that the h's cancel, and we're left with a value of 5. So the derivative of our function is equal to 5. Now we're going to find the domain of f of x and the domain of f prime of x. I'm going to write this up here at the top. The domain of f of x is going to be minus infinity to infinity because our function f of x over here on the left is just 5x minus 4. That is a polynomial, and a polynomial is continuous everywhere. Now let's talk about the domain of our derivative. Our derivative is equal to a constant 5, and that is continuous everywhere. So the domain of our derivative is also minus infinity to infinity. Let's now look at our second example. This is just a classic example to do when you're first learning about derivatives. We want to find f prime of x, so let's start with our formula. I think you'll find if you write the formula down each time you do a problem, you will begin to memorize it. We have f of x plus h minus f of x, all divided by h. This is the limit as h goes to 0. Wherever we have an x, we're going to substitute in x plus h, and this gives us the square root x plus h minus f of x, which is the square root of x, all divided by h. When we plug in that h goes to 0, we are going to get square root of x minus square root of x, which is 0 over 0. That is an indeterminate form. I have a video on evaluating limits with indeterminate forms like this if you need to review that. To evaluate this limit, notice that we have a square root minus another square root. That tells us that we should multiply by the conjugate. Let me write up here what the conjugate is. The conjugate of the square root of a minus the square root of b is the square root of a plus the square root of b. I'm going to go ahead and I'm going to erase the 0 over 0 just because we're going to run out of space if I don't. And now we're going to multiply by the conjugate. The conjugate is the square root of x plus h plus the square root of x. And we're also going to divide by that. And the reason that we have to do that is we can't change the limit. So we can only multiply by 1, which is what we just did. Now let's go ahead and let's use the FOIL method to solve this. I'm going to put parentheses around this top piece so it makes it easier. The FOIL method says the first thing we do is multiply the first terms, and that is the square root of x plus h times the square root of x plus h, so that just gives us x plus h. And now we're going to multiply the outer terms. So this is the square root of x plus h times square root of x. Now we multiply the inner terms, which is minus root x plus h. And then we multiply the last terms, which gives us a minus x, because that's square root of x times square root of x. And all of this is divided by h times the square root of x plus h plus root x. Now let's go ahead and let's see what cancels. We have an x that cancels, and then these terms with the square roots cancel, which is really nice. So let's see what we have left. This is the limit. As h goes to 0, we have an h on top, and then we have an h times the square root of x plus h plus root x. Now you can see that our h's cancel. And then we can go ahead and we can substitute that h is equal to 0. So this gives us an answer of 1 divided by 2 square root of x. And that's our answer. So the derivative of root x is 1 divided by 2 root x. We have one last thing to do, and that is to look at the domains. I'm going to do that over here on the left. So we can write down the domain of f of x. Now, whenever we have a square root, whatever is inside the square root has to be greater than or equal to 0. So our domain is going to be from 0 to infinity. Now let's look at the domain of our derivative. Our derivative is 1 divided by 2 times the square root of x. And because the square root of x is in the denominator, we know that x cannot be 0. So our domain is going to be an open bracket at 0 to infinity.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.